What I wanted to do all of this for is I wanted to connect these up and say, what is the point of mutation? Clearly it's to create diversity, right? Okay. Now, lest I mislead you, when I opened this topic, I suggested that mutations are caused by cosmic radiation. That is one cause of mutation, but there's other ways things can mutate too, right? You aware of that? For example, when DNA reproduces itself, there's a chance it doesn't reproduce itself correctly. Usually it copies itself perfectly, but sometimes some of the nucleotides don't copy correctly, and so a lot of mutations occur just because, so actually the reproduction stage creates a lot of mutations. So reproduction and mutations are closely tied to each other, and there are other ways mutations can happen too. I think standing too close to the microwave doesn't cause mutations, despite what your mom has told you for years. Non-ionizing radiation does not cause mutations. That's kind of what non-ionizing means. However, I've talked to some experts on radiation, and they don't stand too close to the microwave, even though they'll agree with the literature that it doesn't matter. So what does that mean? I don't know. I'm going to stay away from the microwave, even though I don't believe it causes mutations. Superstition, woo. Okay. Crossover is obviously reproduction, right? But cloning is reproduction. Crossover is reproduction plus diversity promotion. And in fact, sexual reproduction is one of the best diversity promoters that we've found. So it tends to be pretty important when combined with mutation. Yeah. Okay, I think the question is, what percentage of the father and what percentage of the mother should be used to create the child? Yeah. Is that what we're saying? Okay, so one could conceivably draw a random number and say we're going to do 0.9 of the mother and 0.1 of the child, and then 90% of the child would come from the mother, and it would end up looking like gata kak. And basically this is the only thing that came from the father, because I drew that random number. That's something to do. Here's what's usually done in genetic algorithms is you're going to pick a random value based on the number of elements in the vector. And let's suppose we randomly pick right there. And then we're going to basically use this portion from one parent and that portion from the other parent. And so that would be uniformly distributed across the length of the vector. Now, for the neural network, I don't know, I kind of say just sort of every time throw a random number, pick a Boolean value, and then pick either the father or the mother. That will probably work just fine too. And I'm not particular about how you implement it. Any of those are probably going to be good. If you're going to make it some set value, I would make it be a random value each time rather than always 90-10. And I would have it be centered at 50%. So it's always going to be half. On average, it should be about half the father and half the mother. But truthfully, maybe it works better if you do 90-10. I don't know. And the answer is run the two simulations, whichever simulation's better, kill the less effective one, let the more effective one survive and propagate it. And then that's evolving your evolutionary optimizer. Yeah. In theory, yes. In practice, the odds of drawing the mother 90% of the 9 times in a row and then the father are pretty low. We could break out the binomial distribution and see what the odds of that happening are. But then again, because it's going to happen multiple times, half the time you're going to create a child and then it's going to mate with somebody else and it's going to put 2/3 of them back. So all kinds of things are going to happen over time, and it gets so chaotic that there's no sense in reasoning about it. It comes down to simulate it and see what happens. And that's going to be my answer for everything, every question you ask me. The answer now is simulate it and see what happens. And sadly, that really is a great answer in AI. That's almost the answer to everything, is why don't you try it? It's open source, go ahead. That type of thing. Okay, do you have a question?
Yeah, but now I know.
But now you know what my answer is going to be, so you don't want to ask. Okay, simulate it, see what happens. Sorry. Okay, well, Tournaments are clearly a selection mechanism, right? I like to do reproduction every time we do a tournament because it makes coding it up easy. But I don't want you to think that's an inherent thing of genetic algorithms. That's Dr. Gashler's cheap hack to making this easy for everyone to do. Okay? I like static size populations because why not? Continental separation, why? Why would we do that? Yeah, I think its purpose is diversity, and same with speciation. Do you agree with that? Yeah, I think so. It looks like a lot of these techniques are all different ways of creating diversity. There's not that many ways of creating selection. What happens on Earth? What ways are there to create diversity? Well, there's failed genetics that doesn't always work out right. Incidentally, I have a sister who has an extra chromosome. That happens. I wish DNA always perfectly did its job. Sometimes it doesn't. Okay? Do mutations occur? Yeah, for a lot of different reasons. So diversity occurs on planet Earth. Is there continental separation? Well, obviously, there's continents. Selection. Crossover happens. What is alive? It's an unanswerable question. Is society alive? I think it is. I think I made a strong argument with, hey, society has all the systems that our human bodies have that we've identified. Therefore, it's probably alive. What about something as simple as fire? I'm going to say fire's a no, right? I mean, fire doesn't have cells, doesn't have DNA, certainly doesn't have thoughts. It's pretty darn simple, and we know what it's doing all the way down to the chemical level, so it doesn't qualify as alive. And yet, think about some of the things it does. Does fire grow? Obviously. Does it reproduce? It's not really a different mechanism, but if the fuel goes two ways, the fire goes two ways, right? Okay. Does it generate heat and light, obviously? Does it consume food? Well, it consumes fuel. Is that the same thing? It's much less selective about its food than biological things are. Does it emit waste? Yeah, I mean, it doesn't poop, but it certainly produces smoke and carbon dioxide and lots of other things. Is fire alive? Well, it's in one of those intermediate stages, right? Well, here's the thing. Does it have what is necessary for evolution? Kinda has that one. Does it have diversity? No. Not so much. Although different things can burn. Garbage can burn, gasoline can burn. Is it the same kind of fire? Different flame colors? Sure. I don't know. Maybe. Does selection occur with fire? I don't know how it would. Well, I guess if it runs out of fuel, one of the ways selection occurs with humans is it's not just fighting, okay? It's not just man versus bear all the time. Sometimes there's tournaments over food, right? The fuel abates and we have to go find the source of fuel, and the creatures most effective at finding food survive. Sometimes selection occurs because warring clans get together and fight over their philosophies. So we have all kinds of tournaments in real life. I could see how it could happen. I don't know. But I think because life isn't well defined, I imagine that pre-life wasn't really alive. I don't think that we necessarily need all of the biological overhead that comes with the human definition of life, because, you know, we've added a lot of overhead to life, right? It has to have cells, cellular encapsulation, and DNA and all this stuff. But our genetic algorithms just need some pretty simple properties. So maybe what originally started out, the first life, probably wasn't alive at all. Pre-life didn't necessarily have to be alive, it just had to be able to evolve.